record. So it looks like I have this little equation here. And now I'm going to turn this percents into decimal, right? That's what we were doing in that section. So 60% is 0.60, or just 0.6. Instead of I put times, and I just copy the rest the way it is. So it'll be times x plus another x is equal to 192. So now when I have decimals, I can proceed solving this equation. So what I can do is to get rid of this 0.6 of this decimal, right? And I do this by multiplying both sides of my equation by number 10. And both sides means I multiply every term on my left side also. So this be 6x plus 10x, right, is equal to 192 with extra zeros. So that'll be something like that, big number. Okay, so next we'll add these two x terms, get 16x. So little by little we solve this equation. So I get 1920 in here. And then to get x, I'll divide on both sides by this 16. So when I do division, I hope it'll fit there nicely. And the advice is just put this in a calculator and get the result. So when I divide 1960 by 16, I will get some decimal. And that's not surprising. We started exercise with decimals, so why not? We can get decimals. It's 122.5, and that'd be our answer. So these so-called little word problems are nothing but turning them into equations. And if you start to think, how else could you possibly write this as equation, you'll see there is only one way. So 60% of x of number plus another number. So it looks like I just write what they say without a hurry, and that's the way to go. So let us move to the next section, the inequalities. That's what we also worked with, and I hope that you remember those type of exercises from your other math classes. So the advice was to look at 5 minus x. So let's see, where is it? 5 minus x is equal to 1. So, well, let me write this down. I don't remember which exercise it is, but 5 minus x, so let me, it's another marker. 5 minus x is less than or equal to 1. So how do we solve this type of inequality? Well, looks like I need to find x just like when we solve equations. And to be able to find x, I start with isolating my negative x first. So I can subtract 5s on the left and on the right, right? So we're going to have a negative x in here. And it's less than or equal to -4. And here comes the part that we noticed differs solutions of equations and inequalities. When you be changing sign with -x by either dividing it by -1 or multiplying by -1, point is you change signs on your inequality, this inequality will reverse its direction, because when you divide by negative, you get, instead of less than, greater. So x will be greater than number 4, greater than or equal to. So this inequality is here. We flip inequality sign. And that's really important little rule that we observed here in this section. Instead of pointing this to X, now it points to 4. So I guess that's solution for inequality. I can make a picture of that. I can put 4 here. Fill the circle with it, like that. And X is greater means X goes to the right. So greater numbers like 5, 6, 7, they all located on the right side from X. So we highlight this interval. Please notice that this interval will be actually infinite because it continues without the end all the way to the right. So it just keeps going and going. So it's infinite interval here. So solving inequalities, again, is analogous to solving equations, but we graph solutions at the end. I also would like to do problem like exercise number maybe 65 here, the double inequality, to see how we can work that out. Double inequality. Let me do it up here in the center. So when I try to solve this double inequality, notice that X is right in the middle. So to work out this double inequality, I'm going to add 5 at every part of my inequality. So I'm going to add it on the right side, in the middle, as well as on the left. So I'll have 2 on the left side, less than or equal to 2/3 of X. That's my middle part. And then it's going to be less than 5 minus 1, which is 4. So inequality produced now is more compact, but it still needs another step. I need to clean this 2/3, right, to get just X in the center. And people use reciprocals. So if I multiply by 3/2, the middle part, as well as the sides, such as right side and left side, again, the inequality is not going to change because they do same thing everywhere, but X will be found. So with the left side, I can cancel the 2's, and I just have number 3 here on the left. And on the right side, I'm going to divide 4 by 2 and get 2 left. So 2 times 3 will be 6. So now it's much nicer. And if you want to picture this result, you'll have X that varies in between 3 and 6, but I need to make sure that 3 is included because of equal sign, right? Since we have equal sign, then I fill the circle to show that 3 is included and 6 is not. So solution of inequalities here. We do pretty much same thing as with equations, but make sure that inequalities flip if divided by negative. Well, that's another part of the story of chapter 6. And finally, last section of that chapter deals with solving quadratic equations. So they deal with the factoring here, and that's very popular procedure. So first of all, they show how they multiply the 2 parentheses together. People say distribute. Well, they like to use this so-called FOIL method because they notice that inside product 3x and outside product 4x are like terms. 3x on the inside and 4x on the outside, right? And that's what they're talking about. So when you produce this 3x and 4x, then they end up being together 7x. And that's what people like to do when they FOIL. So they explain why this is called FOIL, because you multiply first terms, last terms, and then outside and inside terms. That's why it's called the FOIL method. Well, let us try to FOIL this product. So inside and outside. So it looks like I should have this thing away. Clear it out. This mess. So inside, when I multiply 4 by 5, it's going to be a 20, right? X. And the outside product will be negative, minus 9x, because I multiply positive 3 by negative 3. So first term product will be 3 by 5, which is 15 with x squared. That's my start, 15x squared. 3x by 5x. Now inside and outside, 20 minus 9 will give us 11x, right? 11. And the last terms, positive 4 and negative 3 will give us negative 12. So it turns out I just put the answer right away, and that's what they want me to do. And that's actually what they produced on this solution as well. You can see it's also same thing, right? 15 and then 11 and minus 12. So this FOIL method helps us to actually factor various expressions, and that's what they're really after in here. So they say, how about if you factor, did you ever see factoring before? Factor this nice little polynomial, one that starts with x squared and ends with 8. And turns out all you do is you factor x squared with x and x. They just put this in the parentheses. You see this x times x. Everything is positive, so you put plus signs, because if there be minuses, then you would need some minuses. And then you factor 8 as a 4 and 2. And if you wonder if that's right, well, you can always check it by foiling. So inside product here and product on the outside. Inside we have 4x and outside we have 2x. And looks like when you put together 4 and 2, you're going to get exactly 6x, just like they show in here. So I hope this is something somewhat familiar. And if not, then you can just do more of these problems. And I'm going to move to the end of the section and just practice to factor this so-called trinomials today and just see what this is coming to. So looks like these exercises here at the section end, section 6.5. Here it is. So I'd like to clear this mass produced. Share this again. And well, maybe start with exercise 9 that says factor this trinomial. So what I'm going to do is prepare a couple of little parentheses, right? 2 parentheses multiplied together. X squared at the beginning will factor as x multiplied by another x. Signs will be all positives. And how do you factor number 6? Well, turns out there are 2 ways to factor 6. You can either go 6 times 1, but that's not a good idea, because if you use 2 and 3, notice their sum will be 5, and 5 is what I need to have in the center, in the middle, right? So when you multiply 2 by x inside, it's 2x. On the outside, I multiply x by 3, and I get 3x. And when I put them together, 2x and 3x, I'll get exactly 5x. So yes, there was another possibility, was 6 and 1, but 6 plus 1 was 7, so I didn't really care for that factoring. So let us try one more. How about exercise number 12? Factor this trinomial. And again, I'm gonna prepare two parentheses to factor 12 with x that stays in the beginning. So I factor x squared with x and x. I think that's a favorite start. Now, I need to factor -5, the last term. And looks like the only way to factor -5 is -5 times +1. 5 factors 5 times 1, that's the only way. There is no other way to factor 5. So is this going to work? Well, let us multiply and see if that works or not. So when I FOIL on the outside, I'm going to get 1x and inside -5. Yes, it works. How about that? -4x is produced, right? -5 plus 1 is -4. And that's great. Well, sometimes we don't have such a nice start as x squared. I'm looking right now at problem 21. Well, in exercise 21, I'm gonna have 2x squared factored, and this be factored with 2x multiplied by another x. 2x squared factors 2x and x. Now I put plus signs here, and I really like number 3 because it factors only one way, 1 times 3, right? And of course, you want to always double check if that's right or not. So if I multiply 1 by x, I get x, and 2 by 3 is 6, so it'd be 6x. So when we put these two together, 6 and 1, I get 7. Yes, it works. So there are various factorings that we can go through. And well, the point of this factoring process is to be able to use it to solve equations, like an exercise, for example, number 37. Please notice that 37 is equation because it also has that equal sign. Previous group of exercises were not equations. So all I could do was just factor and then stop. Now with equations, I have one more step to perform. The step will be to find a known letter x. So let me factor first term x squared with x times x, right? Everything is positive, so I put pluses. Now, how would you factor number 15? Well, it sounds like 3 and 5, right? Pretty natural factoring of 15 is 3 times 5. And please notice that when you double check and see that the product of inside will be 3x, and on the outside, x by 5 will be 5x, then yes, you will get 3 and 5, exactly 8x in the middle. And that's great. So now we continue. So we factored, but since it's equation, there is one more step I need to perform. I need to find x that solves this equation. So what I do now is I write each factor equal to 0. The reason is that we multiply two numbers and have a product multiplication result equal to 0, which means that each factor could be 0. That's the only way to produce 0. Either have 0 here for first factor or 0 here for second. And that's exactly what I wrote. So we can get answers. They be either -3 or -5. So there are two numbers that solve my equation. And that's good to realize. So it looks like this section deals with algebra, and there are lots of quadratic equations appearing here. And the plan is to, well, solve some of those. So let me do another exercise, maybe problem like 41 for a change. That problem has equation, but this equation needs to be written with a 0 on one side. So I'm just gonna copy all that here. So put minus 21 equals to 0. And 0 is important to have because then you factor and then set each factor equal to 0 like we did in the previous example. So let me start factoring. Prepare two parentheses. Factor x squared with x and x. And can you tell me how would you like to factor 21? I factor with 3 and 7, right? So I put -7 and +3 because product is negative, so -21. And notice that when I have -7x inside and 3x outside, I get -4x as the result. So now I'm going to continue. I'm going to actually to finish with this exercise. So I write that each factor is equal to 0, either first or second, like that. And then find x. X could be 7 or negative number 3. And that's all we need. So we found two answers for this equation. So ability to factor is definitely a great ability. When you say, what if I can't factor? Let me move to the next section and show you what to do if you can't factor. So sometimes, like in exercise number 55, look at that problem, 55. You cannot factor. Cannot factor. Let me clean because it's just way too much here. Stop sharing. Nice and clean page. So I'm at the exercise 55 here. And please notice that if you try to factor this equation, you're not going to be able to. I say, how come? Well, if you factor x squared, there's only one way to do that. It's x times x, right? And plus signs I see in the parentheses. I put in the parentheses pluses because that's the only sign I see here in my equation. And the only way to factor 3 will be 3 times 1, right? So it cannot really do anything else. But when you start to FOIL, you're going to have 3x in the middle, right? And on the outside will be 1x. And it's not 5 because 3 and 1 is 4. It means we cannot factor because there is no other way to break this down with two factors. And that's the reason why they give us an alternative way of finding solution for quadratic equations, so-called quadratic formula. Did you ever see that before? So the formula for solving quadratic equations that in general looks like some number times x squared. Then there's x term and there's like a number like here, for example, we have x squared multiplied by 1. So I can say that my a is equal to 1. And b is equal to 5. And c, whatever is the last number is, that's called c, that's 3. So those are a, b, and c. And the formula says that there is a way to solve all of these quadratic equations by using the answer that comes from so-called quadratic formula. I hope that you heard this word before, quadratic formula. So that's something like that. It turns out the formula does not really care what your A, B, and C are. All you do is just plug them in this formula and get yourself the answer. So let's do that. So first term will be minus b, right? Minus b here. So I put b with a minus sign, so it'll be -5. Then there is a plus and a minus sign up here. I say, oh, what does that mean? Well, we'll see. Let me first plug numbers in. So b squared will be 5 squared, right? Then I need to subtract from it 4 times a times c. So instead of a, I use 1. Instead of c, I use 3. And then I divide this by 2a, which is 2 times 1. So my answer should come from this formula. And this will deal with 25 minus 12. Because I have 5 squared is 25 and 4 times 3 is 12. So this is going to look like -5 plus minus a square root from 25 minus 12 is 13. And this is divided by 2. Let's see, Alex, what a mess. What does that mean? Well, it means we have 2 answers. First of them will be -5 plus square root 13 divided by 2. And the second answer will be -5 minus that square root of 13 divided by 2. So the signs plus and the minus with square root of 13 actually tell you that you have 2 answers. So this plus minus, I write as plus for one answer and minus for the other answer. And those are the answers. When you say, Alex, so what are they? Well, they're here. If you wish, you can always put them in your calculator and you will get some decimals. But point is, they're not nice answers, not like whole numbers that we used to work with. They're just fractional answers. And just leave them in that form will be fine. So if you cannot factor, well, then you don't have much of a choice but use quadratic formula and get your results. Let me try number 62 exercise. Solve exercise number 62. Maybe I'll do it someplace here. That says take equation x squared minus 3x. And I'll put minus 10 here because I want to produce 0. Please notice that all these equations need a 0 on one side. And that's what this ax squared, bx, and c also wants. So I could use the formula. And looks like this equation I can solve by factoring. Instead of using this tedious formula, I could just have 2 parentheses, factor x squared with x and x, right? How would you factor -10? Looks like -5 multiplied by +2. So please notice that if you multiply these parentheses together, you get -5x in the middle and plus 2x product on the outside. And when you subtract 5 from 2, you will get -3. So I don't need to worry about using the formula. I could just solve equation by factoring, which is, I think, much more straightforward because it gives you very nice answers, right? So you get something like 5 for x or -2. So these 2 are my results. And if you decide to use the formula to solve this equation, you can go ahead and do this, but the answer will be the same. So these quadratic equations that have x squared, could be solved either using a formula or using factoring. So I guess today I'd like to just concentrate on these equations because it has quite a bit of material. And again, I truly hope that you already saw how people did this before in your previous math classes. But if not, it's okay. We can just practice and do one more. Let's say exercise number 59. So for exercise 59, which is x squared plus 4x and minus 7 is equal to 0, I cannot find factoring. Why not? Well, if you try to factor, there is only one way to do this. You can factor x squared with x and x, and then your 7 you can factor with a 7 and minus 1, right? There is only one way to factor number 7, 7 and 1. And this doesn't work because when you multiply inside and the outside, you're going to get inside 7x and on the outside minus x. So when you put these together, you're not going to get 4. You're going to get 6. So I have no choice but to use that quadratic formula again. And for that matter, I just identified what A, B, and C were. So A is 1, that's with x squared, right? B is what I multiply by x, it's 4. And now C is going to be negative because we subtract 7. So C is negative 7. All right, we're ready to get the answer. So let's do it. Negative 4, right? Minus B is negative 4. Then I put plus minus signs and have here B squared, which is 4 squared. Subtract 4AC, 4 times 1 times negative 7. Okay. And then I divide this by 2 times A, which is 2 times 1. Okay, so let me see what's inside this square root. This is sometimes called discriminant. So we square 4, get 16. Then we multiply two negatives, negative 4 by negative 7. So it'd be positive 28. And now I have the answer. Looks like we have here the negative 4 in my numerator, plus minus. And the square root I extract will be from 44, right? Divided by 2. So this is a pair of answers. If you wish, you can write one with a plus, the other with a minus, put them in a calculator. But I think it's good enough, just leave it like that, because that's really solution for your quadratic equation. So we're solving various equations, and I would advise you to try to factor, because factoring is definitely more compact and nice looking. But if you cannot, like in the problem 59, well, then you don't have a choice but to go with quadratic form. So I just switched back to the previous section, and I just want to factor some more of these, because looks like we use them to get this nice little equation solved. So far, yeah, looks like homework. We are done with chapter 6 and we're done with chapter 5. So far there be indeed sections of chapter 5 and chapter 6. You're absolutely right. And then next time we'll take a look at chapter 7 and we'll, I guess, have a little bit more of it. So notice now we went a little bit faster because I think material is somewhat familiar to most people, right? So we don't really have to be stuck with section for 2 class meetings. And I guess it's making the class a little bit nicer by the end, right? So I'd like to factor another exercise and then have you try to factor, just to practice factoring. So let me try to factor exercise number 25 that says starting with 3x squared. So I already know that factors will have 3x and x, right? 3x squared, it will be 3x and x. So that's how we start, because we factor first and then we factor the last one. So now I need to factor the last one. And this is number 2. So factor it with a +2 and -1. And of course, you want to make sure you see that this is work. So if I multiply inside, I get 2x. And on the outside, -3x. Then -3 and 2, and that will give me -x, and that be just what I need, right? So that's great. So how about if you try to factor one of these little exercises? So let me find something nice for you. How about problem number 19? So for quiz for today, please factor exercise number 19. All you have to do is factor it. Okay. And as usual, just put these 2 factors in the Zoom chat for your answer. Okay. Just don't worry, please.